Hello everybody, my name's Mark Wild. I'm the CEO of HS2 Limited. We're building Britain's new high-speed railway from London to the West Midlands. Currently at peak production, 34,000 colleagues working on this immense, unprecedented project. A lot's happened since my last update. We've achieved the completion of the Bromford tunnels in the West Midlands, 3.5 miles of tunnelling that completes all tunnelling work between Old Oak Common and Curzon Street. A total of 45 miles of tunnelling. Really pleased to see that activity completed. 10 of the 12 tunnelling drives are now done on HS2. It's also not just the tunnelling. Dozens of bridges and viaducts have been worked on. Of particular note was the Lawley Middleway Bridge Push. Exceptional work, particularly on that viaduct. No disruption to the road users. Superb job done by the teams, and very, very typical of all the work going on across the programme. And of course, milestones to come in the future. We are completing the Curzon 2 bridge. You'll see it on the train as you pull into Birmingham. We're changing the skyline of Birmingham, and that bridge will be completed in the coming months. Of course, despite all of the great achievements of production in this year on HS2, we're not where we thought we would be or where we'd planned to be. When we started this project at the notice to proceed in April 2020, by now we had intended to have completed the civil engineering and also be well on with this project. Well over half complete we should be in terms of the whole system, because of course we're not just building a civil engineering project, we're building a railway. It is a complete system. It includes the track, the overhead line, the electrical engineering, the train, the depots, the sidings. All of these things come together in a singular system, and we're behind. And that's why we're resetting the program to get everything back into the right sequence. Several external reasons, of course, about why HS2's program has fallen out of sequence, but I found 3 enduring problems that we will fix in the reset. Firstly, we've started construction before design has been complete. Secondly, we have contracts with our supply chain partners that don't encourage good performance. And thirdly, HS2 Limited was really not set up to deliver the whole system. Now, these 3 enduring problems will be addressed in the reset. So what's the reset all about? It's about putting all of the activities for the whole system back into the right order. How do we do that? Well, we go to the end of the project and we work backwards. That's important because the day this railway opens, it has to be safe, reliable for the customers that get on the trains and the operators who operate the system. We've spent the past year working out in great detail all of the dependencies between the building blocks of HS2, working out the sequence of the work. Of course, we have to deliver this job for the lowest reasonable cost in the fastest time, but we have to have 2 feet in reality to do the sequence in the correct way. We found in Crossrail that if the civil engineering became overlapping with the electrical engineering, with the testing, we really had problems with productivity. The best way to get this job done is to do the building blocks in the correct order, complete the civil engineering, give access to the track and the overhead line, then do the electrical engineering, then bring the systems on board, and finally, of course, bring the whole system together in testing and provide enough time for operational proving at the end. This is what we did in Crossrail, and it's what we're doing right now. That process is well advanced. I look forward to sharing more of that in the future with you, but you can be assured this reset is the reset that will hold to the end of the job, and we will break the cycle of continual cost increases and delays that obviously undermine confidence. While we reset, it's important we keep productivity up on site. 34,000 brilliant colleagues working on this program from 3,500 UK companies. One of the biggest engineering projects ever undertaken in this country, unprecedented in its size and scale. And I'm really proud of the teams working so hard out there, making every pound count while we reset. Of course, safety is intrinsic in that. We have a belief and an ethos here of zero harm, nobody getting hurt on this program. I'm really pleased about our safety performance, but of course, we've got to continually work on that. And we all know that good safety will lead us to good productivity and lead us to the opening of the railway. Okay, everybody, more in the future, but hopefully that's given you a flavour of how we're resetting and while at the same time we're maintaining productivity on site. Thank you very much.
High in the Himalayas, where the mountains scrape the sky, a river is born from ancient glaciers. It begins as the Yarlung Tsangpo, winding through the heart of Tibet, revered for centuries as both a lifeline and legend. Its journey spans nations, flowing across China, entering India as the Brahmaputra, then becoming the Yamuna in Bangladesh, before merging with the Ganges and Meghna to meet the Bay of Bengal. Along its path, it sustains millions, feeds fertile plains, and shapes the cultures of 3 countries. Yet, in southeastern Tibet, this mighty river transforms into a force unlike any other. In the Great Bend, it plunges more than 2 kilometers in just 50 kilometers, an untamed descent through the world's deepest canyon, roaring with enough energy to light entire nations. Now, China has set its sights on harnessing that raw power through a colossal megadam expected to generate nearly 3 times the electricity of the Three Gorges Dam, the world's largest and most powerful. But this engineering ambition carries a sharper edge. For downstream nations like India and Bangladesh, it raises fears that China could one day control or even curtail the vital waters that have sustained them for centuries. Today, let's delve into China's $170 billion Medog hydropower station. Don't forget to click on that subscribe button and like this video, as it's the best way to support this channel. The Yarlung Tsangpo is among the planet's most extraordinary rivers. Rising on the Tibetan plateau, it meanders east before taking a dramatic turn around the Namcha Barwa Massif and plunging into the world's deepest canyon, the Great Bend. Here, over roughly 50 kilometers, the river falls an astonishing 2 kilometers, creating a hydraulic drop unmatched in scale and intensity. Medog County lies just upstream of the Indian border in a region of steep gorges, seismic instability, and heavy monsoonal rains. It is also a biodiversity hotspot, where tropical and alpine ecosystems converge within a few horizontal kilometers. This combination of immense energy potential, challenging geology, and environmental richness makes the Great Bend both an engineer's dream and a conservationist's nightmare. Harnessing this river promises gigawatts of power, but demands construction in one of the harshest and most fragile terrains on Earth. For decades, Chinese hydropower planners have eyed the Great Bend as the ultimate untapped prize. Early feasibility studies and policy proposals date back to the 1990s, but the political and technical hurdles were daunting. The region's remoteness, volatile geology, and sensitive geopolitical position, just kilometers from a disputed border, kept the idea in the realm of ambition. That changed with the 14th Five-Year Plan, which explicitly called for exploring a massive hydropower base in the Yarlung Tsangpo. In December 2024, China formally approved the Medog project. In July 2025, Premier Li Qiang presided over the groundbreaking ceremony, framing it as both a contribution to China's climate targets and a strategic infrastructure investment to encourage growth. The project's approval came at a time when China was doubling down on state-led megaprojects to revive its economy while accelerating its transition away from coal. Medog is not a single colossal dam, but a run-of-the-river cascade made up of 5 major hydropower stations, cut across the river's dramatic 2-kilometer descent. Rather than building one huge wall that floods the valley, the system works like a ladder. At each stage, water is diverted from the river into a small pool, then funneled through long tunnels, some stretching over 15 kilometers, into underground turbine halls where electricity is generated. After passing through the turbines, the water flows into another balancing pool further downstream, ready to be captured again by the next powerhouse. This process repeats across all 5 stations, with the water finally returning fully to the river after the last stage. When complete, Medog will have an installed capacity of 60 gigawatts and produce about 300 terawatt-hours of electricity annually, roughly 13% of China's total consumption in 2024, enough to replace hundreds of coal plants. Because Tibet is far from China's main industrial hubs, ultra-high voltage transmission lines will send this power thousands of kilometers to provinces like Guangdong and Zhejiang, helping meet peak demand and steadying grids that rely heavily on wind and solar. Beyond electricity, the project will boost industries such as tunneling, turbine manufacturing, and transmission technology, and could serve as a model for large-scale hydropower in mountainous regions worldwide. Building the Medog Cascade is both an engineering and logistical challenge on a scale rarely attempted. The Great Bend is one of the most remote and difficult places in the world to build a hydropower project. Before any major works can begin, crews must create access, temporary bridges, steep mountain roads, and cable systems to move heavy equipment across slopes that can exceed 70 degrees. Once access is secured, the tunneling begins. Long headrace tunnels will carry water under immense pressure, so the surrounding rock must be reinforced with sprayed concrete, rock bolts, and in highly stressed areas, thick steel linings. Workers will face hazards like sudden rock bursts, when trapped stress in the rock explodes outward and water leaks from underground sources. The underground powerhouses, each around 200 meters long and large enough to hold several massive turbines, must be excavated and supported in stages to prevent collapse. Given the region's seismic activity, every tunnel is designed to survive strong earthquakes, with flexible joints, extra thick linings, and real-time monitoring to spot stress changes early. Stabilizing the slopes is equally critical. Retaining walls, anchors, and drainage systems protect entrances and access roads from monsoon-triggered landslides, which can be worsened by blasting. River diversion adds further complexity, requiring temporary dams and bypass tunnels strong enough to handle extreme floods. Weather shortens the workable year. Winters are harsh, summers bring heavy rains. To stay on schedule, different parts of the cascade will need to be built simultaneously. Throughout, the design layers in backups and contingencies, aiming to capture the river's vast energy while keeping its immense power under control. Medog's projected cost exceeds 1 trillion yuan, financed through state-owned hydropower giants, national policy banks, and infrastructure bonds. The funding model reflects China's capacity to channel state capital into politically strategic infrastructure, absorbing risks that private investors would avoid. Groundbreaking took place on the 19th of July, 2025, marking the official start of construction. The build is expected to run through at least 2033, with early phases devoted to site preparation, geological mapping, and pilot tunnels to confirm rock conditions before full-scale excavation. Major civil works, tunneling, cavern excavation, and intake construction will advance in overlapping stages. Turbines will be installed and commissioned sequentially, allowing partial power generation from around 2030 while the remaining cascade is completed. Full commercial operation is anticipated by 2033, though in a setting as geologically and climatically challenging as the Great Bend, unforeseen rock conditions or extreme weather could extend timelines further. The Medog hydropower station faces a challenging mix of environmental, engineering, and political pressures. The lower Yarlung-Tsangpo Gorge is a fragile landscape with steep slopes rich in biodiversity and sensitive ecosystems. Even with small reservoirs, construction will fragment habitats and disturb wildlife, while altered sediment flows could harm soil fertility and fisheries far downstream. The region's geology heightens the risks. Heavy monsoon rains, fractured rock, and seismic activity create constant threats of earthquakes and catastrophic slope failures. Tunneling and blasting can destabilize mountainsides, and monsoon-triggered landslides could endanger both workers and infrastructure. Adding to these environmental and engineering risks are deep diplomatic sensitivities. The absence of a basin-wide water treaty among China, India, and Bangladesh amplifies mistrust. Hydrological data sharing is limited and seasonal, leaving downstream nations reliant on Chinese assurances. In India, where the Yarlung-Tsangpo becomes the Siang and then the Brahmaputra, suspicion runs deep. Some leaders, including the Chief Minister of Arunachal Pradesh, have even warned that a dam of Medog scale could become a water bomb over the northeast India. Critics fear it could give China the ability, during times of conflict or political pressure, to alter or withhold flows, disrupting agriculture, hydropower, and the livelihoods of millions of Indians. Bangladesh, at the river's delta, fears reduced dry season flows and worsening saline intrusion, threatening agriculture and water security. China insists Medog's run-of-the-river design makes large-scale manipulation impossible. Yet, in geopolitics, perception often outweighs engineering reality. In a tense climate, even routine operational changes could be read as deliberate acts, turning a dam into a geopolitical flashpoint across South Asia. If delivered as designed, Medog will be one of the most productive renewable energy assets ever built. Its steady high-volume output could displace hundreds of millions of tons of carbon emissions, anchor China's transition away from coal, and provide a backbone of firm, renewable power to balance an increasingly variable grid. Yet its ultimate legacy will hinge on more than technical achievement. The true measure will be whether China can execute it without triggering irreversible ecological damage, and whether it can build frameworks of trust with downstream nations that turn suspicion into cooperation. In the Great Bend, gravity offers almost limitless power, but in a shared river system, that power carries responsibility. The Medog Dam will be judged not only by the electricity it generates, but by the stability, transparency, and goodwill it fosters or fails to foster in the years to come. What are your thoughts on this megaproject?
3, 2, 1.